Welcome to today's episode of the Cross Labs podcast, On My Mind.
So I guess we're going to talk about chance versus contingency in technological development.
I'm just wondering how come technology stopped developing so fast. All of those movies in the 80s that predicted flying cars, thinking about the Back to the Future movie, but then they never happened. What happened?
I mean, people's vision for the future is not the direction that things end up developing. I mean, like we all lived through the AI boom, and that has eaten careers in, physics and A-life and whatnot and turned us all into AI scientists because it was just so fast.
I guess before AI, it was the internet.
Even before then, it was computing.
We don't realize the big change that it's going on while it's going on because it's not something like a flip of a switch. That is something that we see after a couple of years. If we look back, the invention of the internet changed humanity like from one day to the next, but no, it wasn't like that.
I don't know if with AI, I think it was very visible when it was happening.
For a regular person using anything on their phone, they're using AI, so I should not finish that sentence. Goodbye.
Yeah, I can believe that there are people who didn't notice it happen. And there are a lot of people who don't notice a lot of things happening because it's not relevant to their way of life.
It seems like technological progress is exponential only in one domain, I guess. Right after World War I, it wasn't in one domain at a time. It was in so many different domains at a time. Maybe because it was fundamental physics, it led to a huge explosion in all sorts of different technologies versus we haven't had that fast of a leap in fundamental physics since then.
Well, I don't know. It feels like it's a lot based on subjective needs by humans, as in pyramid of needs. The small fraction of the population that is writing articles and paying attention to this stuff is having their needs fulfilled. And I guess the other effects are a bit more long-term or harder to see economically or quality of life-wise, that we're sort of stagnating right now.
There are other issues in the world that don't have to do with technology that we've had quite a lot of in the last decade. Major pandemic. Oh yeah, and we seem to have tons of war these days as well. Yeah, I don't think we have to look at a failure of the progress of science to explain why we're having a bit of a downturn here.
Well, growth is still exponential, at least in hardware tech.
No, Moore's Law ended. It's supposed to double every 2 years, but they keep redefining Moore's Law because basically over a decade ago, clock speed stopped going up. And so they're like, oh, no. We actually mean parallelism so that we can still justify selling new stuff. For a given task that you're doing on your computer, using a word processor today is not a smoother experience than it was 15 years ago.
Well, by that, you're measuring with the wrong one. Like if you're going to measure the performance of a computer with Notepad, then yeah, probably.
Nothing in Notepad can really be parallelized. It's all serial processing. It's essentially your CPU speed, and that's been static for over a decade now.
Okay, but that's one specific stuff.
That's anything that doesn't have any kind of massively parallelizable aspect to the task it's for. Something like a word processor where it's really the responsiveness to your input that matters. It's not getting any better. It's getting worse, actually, because the general tendency in software is for programming to get less efficient when there's headroom. If you're doing AI stuff, yes, because that's very naturally parallelizable. But there's a lot of stuff that isn't AI stuff, and that stuff is not getting any better. There's sayings in programming like premature optimization is the root of all evil. And so what people will have a tendency to do is they will favor less efficient solutions at the consumer running level as long as it, kind of doesn't matter in exchange for having things that are easier to program in and easier to maintain. If I can get away with using something that is a bit slower on the consumer side, but everyone is supposedly as flush with resources now and save myself a factor of 10 in programming time, yeah, I do that, right? I mean, just look at the minimum hard drive size to have an operating system these days. Luke, when you write 1 GO for Linux, do you mean...
No, it's literally 1 gig.
Yeah, 1 gig is huge. I guess this is kind of my point. Yeah, you could do, I don't know, what was I using 15 years ago? Green Frog Linux, which is probably 50 megabytes. And you could still do that nowadays. But no one is going to do it because it's I have my, NVMe drive and I have terabytes and I've got 48 gigs of RAM. Am I going to spend weeks of my life compiling every single thing I need on the system? It's not like I'm going to go higher because I can. It's I'm not going to go to any effort to not go higher because my hardware means I don't notice the cost of going higher. But this stuff becomes relevant again when people want to run things on, Raspberry Pi or whatever.
Oh, a guy ran Stable Diffusion XL with a Pi.
I mean, I'm sure it was extremely painfully slow. The more impressive thing is that the minimum VRAM requirements to run that on, like, without doing something fancy is like 12 gigs, I think.
Well, yeah, but he did in 256 megabytes.
Yeah, and there are tricks you can do, like running each layer separately and loading the weights on the fly and, splitting things into patches and all of this stuff, which I assume that's how they did it.
Yeah, exactly that's how they did it.
That's it for this week's episode of the Cross Labs podcast, On My Mind. Don't forget to like and subscribe so you'll be the first to know when the next episode is out. Thanks so much for tuning in, and we'll see you next week.